From the years 1972 through 1992, HP produced this 8660 RF signal generator. They made 4 versions, A, B, C, and D. My version that you're looking at is the popular version, C. I'm not sure how long of a run it had, but it is from the mid to the late 1980s. I haven't opened mine up to look at it to try to get any better of a date code off of any components. I did open up the bottom and then I immediately put the cover back on. It was not that easy accessible to the components. This is a lab grade RF signal generator, and when it came out, my particular version here cost $30,000 with the 2 modules. HP calls this main unit a mainframe because these 2 modules right here are removable by simply grabbing that and then finish pulling it completely out. I won't be doing that in this video. Pull those modules out. I had a heck of a time putting it back in, although one day I just might, because I need to service and clean the controls. That will not be done in this video. I also need to clean the fan, and again, not in this video. I will fire it up and you'll hear how extremely loud this device is. This is a device you could hear throughout the entire house. And speaking of obscenely large things, well, the sheer girth of this device is not for soy boys. No, no. This thing weighs 61 pounds. So if you cannot lift 61 dead pounds all by yourself, definitely get help. It is a very heavy device. It may not look like it in this video, but this device is extremely large. From the front of the handle all the way back to the back of the foot, that is 24 inches. From side to side, you're at 17 inches. And for the height, you're at about 7 3/4 inches. A really massive machine. Go ahead and hit my kill switch. And let's turn this on and listen to the awesome noise the fan produces as well as the awesome display. I do have to say, this is an awesome piece of gear. And these 2 modules right here, this is the modulation section, and my particular module is AM/FM. They did sell these in different flavors, including with a pulse. This section right here is a RF section. Now my RF section covers 1 meg to 2.6 gigahertz. And in my testing, I've actually found that it goes a lot lower than 1 megahertz. Definitely usable for my needs. My needs is radio repair. And I'm okay if this version, if my model don't go quite that low. because I have my B&K multifunction generator, which covers from DC to 21.5 megahertz. So currently I'm fat and happy. At one point I will go ahead and pick up the other module, which covers 100 kilohertz through 110 megahertz, which again is more than comfortable to work on AM FM portable radios, and that's going to be my mainstay with it. And what happens when you do go below the 1 megahertz spectrum? You'll get this out of range light, but it is very usable, and you can see the RF section is still transmitting at its full potential. However, the RF section does decrease the lower you go out of range. And when it goes to your 2.6 gig, as you see, you have to go to 2.5 to get your 2.6 gig. And as you see, we're at 1 hertz. Not much on the RF output. Again, even though the RF output is low, it still does produce something. So I think in my scenario where I'm just working on radios and I don't need a lot of power, maybe on a frequency counter that is not as sensitive, this will do just ducky for my needs. In the rear, you have a 10 megahertz input, a 10 megahertz output, and then a communication port, which is the HPIB. You got the big wonderful fan, you got your power, and there's a fuse in that section right here as well. I wanted to show you this at this stage. As I'm getting ready to put it in place, I will not have an opportunity for quite some time to actually pull this out and do another video on it. It's very heavy. I went ahead and pulled the top off so you could take a peek at it. I also decided I'm going to try to clean the fan, put some oil in it, try to quiet it down a little bit. So I'll just glide across the top so you can take a peek at all that HP wonderfulness. So here's marked reference divider. Plus 20 volts, 100 kilohertz output, 400 kilohertz output, 100 kilohertz output, 2 meg output. This here is our reference divide by 2. This is reference phase detector. 1, 5, 10 megahertz reference output or input, a plus 20 volts and a negative 10 volts. And this here is marked our reference oscillator. We have 500 megahertz output, 10 volts, 100 megahertz output, 20 volts plus output, plus 20 volts, 20 megahertz output, and 10 megahertz output. And a lot of reflectivity from my lights off of this wonderful aluminum and gold. And this is a frequency extension module. We have detector and a bunch of other things I have no idea. This right here, this is the modulation module, and it does slide in with this guide on top and bottom. There's a piece of plastic or something that's fastened to it, and it'll glide in on these channels. Here's the RF section. As you can see, it's a lot bigger. And down here is our filter network in the AC supply area. Pretty massive. Those are really, really big capacitors. So it looks like from here we just remove these two screws and then this will pop out. I'm sure I got corresponding screws on the other side as well. Went ahead and stood it up on its face and pulled the bottom cover off. Take a peek here. We got the fan, and this is on a hinge, so I think all I had to do is just unscrew those two corresponding screws, and that should hopefully hinge over. I haven't done that yet. So here's marked RF switch. Not sure what the board's all about, but we do have a fuse up underneath here. So I'm going to say this is all part of the power supply section still. The bottom side of the two modules, this is the RF section, this is the modulation section. Not sure what that is. This here is marked SL1 oscillator, SL1 mixer, N1 oscillator, N1 detector, SL1 detector, N2 detector, N2 oscillator, SL2 detector, SL2 oscillator, N3 detector, N3 oscillator. And it's kind of interesting how they've got this black line that runs all the way down. That way you could ensure you've got the modules put back into place properly. And down here it says machine state code, auto TP, man SW, man switch, manual switch, man TP, test point maybe, state, and then A1 through A5. And this is 1, 1, 2, 4, 8, 1, 2, 4. So I wonder if that has to do something with the HPIB. And you see the little gold coils? That has to deal with the push buttons, the keypad. If you Google search this device, you'll find a guy who's torn the face off and demos all that for you. I pulled the 2 screws off of the front, and this indeed did hinge right over, which is kind of cool. And it uses a boxer fan, model number WS2107 Foxtrot Lima-55 for those that care. 115 volts, 0.24 amps, 50/60 hertz, impedance protected. So if you ever need a replacement, now you know what it is. Looking up underneath here, we have a power resistor and some transistors, which definitely need a good cleaning. I also did want to notate that my model here came from the military, removing one of the modulation module. There was a military tag up underneath there. We also have another fuse back here. I did want to mention that. So if yours blows and that fuse doesn't fix the issue, most definitely open it up to replace that fuse there. Here we can see the reference ports a little better. So our transistors do read 2N3055, and that's the same. That's the same. This one here is a 2N3791, and they're all dated 80 of 13. And these right here are Motorola 2N3740, that's dated 80 of 39. And I really can't make that out. Too small for my bad eyeballs. So we have a date code of 1980. So now we know how old it is, my model. Here it is several hours later. And no, it's not that. It's taken me that long to get the fan out. I actually needed to figure out how to tear it apart. There's no instructions online. I never really tore one apart before. And they're a lot different than computer fans. Had a snap ring in place. Didn't have any snap ring pliers, so I went down Harbor Freight, picked these up, and then the control here to go forward or reverse, external, internal, wasn't working. It was just locked into place. I had to tear it apart, loosen it up, and at the factory they tightened this screw down so doggone tight. This just would not work. So I got that, oops, wrong side. There we go. So I got that control working. And the pliers seem to work okay. Did their job, what they're supposed to. So after getting the lock washer out, I was presented with a dust cap, and after I got that dust cap out, had an O-ring, and then I had this oil cap. And I'm still unable to pull this fan completely apart, because way down deep in there is another ring that I just will not be able to get out. The nibs or whatever you call them for the tool are not small enough. So the fan will defeat me. There is oil in there. I'll go ahead and put some more in there. Reassemble everything. Clean up. Put the case back on. Clean up my workbench where it's going to go. And hopefully get it stabbed in tonight. And then I can finish the video out and test and show you. If not, then tomorrow. Of course, you won't know that in video magic. It'll just be the next scene. Have the unit put back together, and I have powered up, as you could tell, obvious. The fan definitely sounds much better. I also want to apologize for the quality of this video. When I tested this camera out, the video didn't look too terribly bad. Yes, I know I'm shooting at 640 by 480. This is a vintage camera, and I was okay with that. But I didn't realize that in some of my shots, if not most of my shots, I got a little closer than I should have. This camera does not have macro mode, and about 10 to 12 inches is about as close to the subject as I should be able to, or close as I can get to it. But it looks like in review I had gotten closer than that in a lot of my shots. So for that, I do apologize. I will revisit this device in a future video, but I will not tear it apart and look at the guts and all that stuff. In the future, I do plan on tearing the face out so I can clean up all my switches, but I don't think that that will be a video. So with that said, and as I'm Captain Obvious, the device is powered on, and I've got it going into a frequency counter, a leader LDC-825. This is a 1 gigahertz frequency counter, and before I finalize this video, I thought that if you stayed with me this long, I should at least show you this thing in operation, and that's what we're going to do right now. So you can see right here, you power it on, it goes to a default of 1 meg, which is the bottom of the band. And so that's what I have right here is 1 meg, and I've got this at 45-second delay. I'm sorry, 0.4 second delay. What happens when you have bad eyeballs. And as I stated, I wanted to show you that this does indeed go lower than the 1 meg spectrum. And as you can see, the RF is still pretty full, and I do have it up on 0 dB or 0.3 volts. So you see the sensitivity on that frequency counter. And you get to see that this device does actually go a lot lower than the 1 meg. So let me put this over here on high side. As stated, this is a 1 gig frequency counter. And so that section starts at 50 megahertz. Unfortunately, that frequency counter doesn't go that far. I believe I've logged it in at, I think, 1150. Oops. I did too many. Okay, that'll do it for this project. Thank you for watching, as always, and have a great day.